Hello everyone. Today we are going to discuss about VLIW architecture. VLIW stands for Very Long Instruction Word, and in this architecture we have instruction words in hundreds of bits in length, and multiple functions units are used concurrently. So all functional units here are use of common large register file. So you have to write this architecture. If you observe here, we have a large register file and different functional units like load store unit, floating point, add unit, integer ALU, branch unit, and we have a main memory, and at the same time we have, so we are executing. So here this is a typical VLIW processor. Degree m is equal to 3. So in figure we can see the VLIW execution with degree m is equal to 3. So usually they will ask for 8 to 10 marks. So I have to write this diagram, and it is similar to the superscalar architecture. So next we will discuss about virtual memory technology, and so in virtual memory models we have two types of model. One is private virtual memory and shared virtual memory. So we have private virtual memory and shared virtual memory, and then if you see the private virtual memory space, so we have a physical memory, so which is divided into pages. It is also called as page frames, and we have a virtual space of processor 1, that is again this virtual space is divided into pages. Similarly we have virtual space of processor 2. So we have a private virtual memory for each processes, okay, of many programs running, and we are mapping the virtual memory pages to the physical memory pages. So the main advantages of using the private virtual memory is the use of a small processor address space, so that is 32 bits, protection on each page, and use of private memory maps, so which requires no lock. So each has its own virtual space, so there is no need to lock that memory space, and so this is all related to private virtual memory. And if you observe, this one is globally shared virtual memory space, and here if you see a virtual space, and we have a physical memory, but the virtual space is divided among all the processors. So here you are using only a single virtual space, and some of the examples of this type of machines are IBM 801, RT, RP3, System 38, and HP Spectra. So the list goes on. Okay. So the advantage in using shared virtual memory node, that all the addresses on the virtual space are unique, but each processor must generate addresses larger than 32 bits, such as 46 bits for a 64 terabyte address space. Okay. So compared to private virtual memory, the address, so in this case it was only 32 bits, but here the size is more than 32 bits, and page table must allow shared accesses. Okay. And we also need locking, that is mutual exclusion, is needed to enforce protected access, because two processes cannot access the same virtual space. So we need some mechanism, that is mutual exclusion locking system is needed. And so these are the two major models, that is private virtual memory or shared virtual memory is used. So both has its own advantage as well as disadvantages. Okay.